Hi guys, welcome back to this channel. If you are new to this, hit the subscription button and press the bell icon to get the latest updates. I once again welcome you to this series that is 30 days of coding in Java. Hi guys, I am Nayas from Tecnico MDN. Today I will explain how to solve day 10 challenge that is on binary numbers. So let's get started with the day 10 challenge that is binary numbers. So the task here is they will give a base 10 integer that is n. We have to convert it to base 2 binary number. Then find and print the base 10 integer denoting the maximum number of consecutive ones in n's binary representation. So it is little complicated to understand. So I will explain in detail about this problem. So as you can see, the input format is just n, and the constraint is n lies between 1 and 10 raised to 6. So the output format is we have to print a single base 10 integer denoting the maximum number of consecutive ones in the binary representation of n. So basically what is the thing is, let me show you by using the calculator. So let us go to programmer calculator, and in decimal let us give 5. So as you can see, the binary number conversion is 0101. So the consecutive ones in the binary conversion is only one, right? There is no continuity between 111 like that. So 0101. So there are only one consecutive number, that is 1. So the output will be 1. So similarly here 13 is given. Let us check it out. If we give 13, so you can see 1101. There are two consecutive ones. So the output is 2. So this is what they are asking us to print the numbers. So let us let's get started with the problem. So basically in the public solution, what they have given is they have used one scanner class and void, that is command line argument, and followed by a scanner. So let's get started our code here. So what we have to do is, let's see, once again given a base 10 number, so we have to input n. They have already used it, so we have to directly start coding here. That is we have to take, let's take int num equals 0 to assign it. Then let's take x equals 0 and also take y equals 0. You will get to know why I am taking these three variables. So let's put a condition, that is while condition n is greater than 0, then num equals n mod 2, and next n equals n by 2. So as you can see, I am using two conditions, or we can call it as two calculations. So if the number is greater than n, so we are dividing it, if we are modding the number and again dividing it. So next, if num equals 1, then we will increment the x value by 1, and if x value is greater than or equal to y, then we will assign y equals x. Let's close it. So after this we have to write else part. So we will write the else part after this entire if statement, that is else x equals 0. So let's close the while loop, then the scanner is closed. So here we need to include one statement, that is system dot out dot println of y. We have to print y, right? That is we are assigning. So let me explain you the procedure what we are doing here. Basically, we are applying the condition while n is greater than or equal n must be greater than 0. If it is true, num equals n mod 2. So num equals n mod 2, what it gives is, let's see the in calculator. For example, let's take the example of for phi itself. Let's go to the scientific calculator, and n refers to 5. So 5 mod 2, so it gives 1. 5 mod 2 is 1. So let's keep it in mind, it is 1. And next, n equals n by 2. So let's clear this one, that is n is f 5 and divided by 2. So it is giving 2.5. So next, if num equal 1, as we saw 5 mod 2 gave us 1. If num equal 1, that is there exists one consecutive, only one consecutive number, so followed by we are incrementing x by 1. So previously x is equal to 0, then we are incrementing x value by 1. So if x is greater than or equal to y, basically y is 0, x is obviously greater than y, so we are assigning y to x. To avoid the duplicacy, we are directly assigning y equals x. So the y value become 1, and it will directly come out of the entire while loop and it will print the y as 1. Right. So if we give, let's check another example, that is 13. So let us see 13 mod 2 gives us 1. So it is right. So if one num equal 1, so it is true, x plus plus is x will be assigned to 1, and it is incremented. 1 is greater than or equal to y, it is also right. So before that, let's calculate the n by 2. How much is this? 13 by 2 is assigned to n, that is 6.5. Remember that if num equal to 1 is condition is true, and followed by x plus plus, we are incrementing the x and assigning, so x value will be basically 1. So after coming out of the loop, it will be printed as 1. But since the n value is greater than 0, that is previously we didn't completed the entire thing, so we will complete it now. That is you remember 6.5 is assigned to n, so 6.5 is greater than 0, again it will come to this position, num equals n by n mod 2, 6.5 mod 2, it gives 0.5. So if num equal 1, his condition becomes false, else part x is assigned to 0. So here you can see how it is converting 1 1, next is 0, next similarly 0.5 is greater than 0, the condition becomes false, so it will come out of the loop and just print 2. So you can see the number of loops, right? 2 loops are performing, so it will be printing as 2, as you can see here. I hope you have understood. If you're not completely understood, you just try to trace this part on your own on a paper, so you can get complete perfect idea. So let's quickly run it. So as you can see, the condition 0, test case 0 and test case 1 are satisfied. Let us submit it. So there are about 9 test cases. So as you can see, all the test cases are passed. I hope you have understood the concept. I hope this session was helpful. Thank you. Meet you all in the next video.